Well, hi everyone. I'm John Dellaverson. This is the talk on NDN Plug and Play. It was a team effort from a lot of folks at the UCLA IRL lab, and with that in mind, let's go ahead and start. So a reasonable question, reasonable question someone might have given the name of this talk is, what is plug and play? So plug and play usually refers to physically plugging in a device and requiring zero inputs, or in the case that we're using it, referring to the case where it's very easy to use something when it's first connected. In particular, we're talking about it in the context of plug and play and IP, where from the user's perspective, you connect your computer or your machine to Wi-Fi or Ethernet, and you're sort of free to go about your business, referring to that sort of ease of setup. And we're sort of separating this into two stages. First, configuration. This is the plug step. This is actually configuring something into its operational network environment. And then connectivity, which is being able to send and actually receive packets. And we hope to sort of examine how these steps differ from IP and NDN, learn something from it, present our work on the topic. So with that in mind, let's move into IP configuration. So one reasonable abstraction of IP is pipes connecting all the nodes in the IP global network. And the goal of IP network, which sort of arises quite naturally from this abstraction, is connectivity to the global internet, being able to talk to any other sort of configured IP node. And so IP configuration is then plugging a node into that existing connected IP infrastructure. And so let's sort of make this a little bit more concrete. For an example, we have the global internet that sort of everything is in. We've taken some snapshots both at college and at home, and they're both connected to the global internet, and in one way or another to one another. So let's suppose, and I should note that we have some arbitrary addresses down at the bottom, but let's suppose some sort of crazy event forces you to move your machine from your work to your home on a long-term basis. So in IP, what this sort of means is you unplug from one place, you move, and then you plug into the other place. And we'll note that specifically here, you're plugging into this already existing sort of address space, this topology that was already set up. And then once you've sort of physically moved your machine to do configuration, you essentially just run DHCP, you get your address, you get your default gateway, maybe a DNS server and a subnet mask. And once you've done that, your configuration is complete and you're sort of connected. You're good to go. And there are sort of some interesting consequences to this simplicity. One of them is that because IP is just concerned with connectivity, everything involving trust is happening on some higher layer. You don't actually know if you're talking to the right person over IP. This introduces some vulnerabilities. You can have source address spoofing because you can't tell who you're actually talking to. As a consequence of that source address spoofing, you can have redirect attacks, and particularly bad DDoS attacks. And just to bring in an interesting biological analog, some of the same selection factors that rule viruses on the biological level also govern how viruses on the software level evolve. And we'll note that on the biological level, there are relatively few points of ingress or egress, and all of them are guarded quite fiercely. The body doesn't trust foreign bodies essentially at any time and tries to reject them. And so in some sense, we can think of this lack of security as being unnatural. And none of this, I should note, is to bash IP. IP works wonderfully for the purpose it was designed to. It's just some things in networking have changed since it was first introduced. And we just want to acknowledge those, since we hope that they can be improved. So now we can move on to the second stage of what we were talking about in plug and play, the play part, connectivity. And for IP, this is actually pretty trivial once configuration has been established. You either send it to the local network, if it's on the local network, or you send it to the default gateway. And though true routing, and then because IP assumes that routing protocols are being run by the network, this is sort of masked from the end user. The true end-to-end, how everything gets to from one end to the other is a little bit more complex, but it's irrelevant for the edge user or someone who's interested in the plug and play aspect. So we'll avoid it for this talk. And now we can get to what may be a more interesting part of the talk, or sort of the meat and potatoes of it, which is NDN configuration. And we'll start off with the plug stage as opposed to connectivity. So what is NDN configuration? If IP configuration is plugging some entity into that topological existing connected IP infrastructure, NDN configuration is plugging a new entity into an application namespace. And because trust relations actually exist within the space, you inherit the trust relations of that namespace with other names. And I should briefly mention that in general, the application namespace we're talking about by default is inheriting the DNS namespace. And because you're asserting trust dynamics at this stage, this is more or less the security bootstrapping stage, establishing authenticity here is critical. If you mess up the security bootstrapping, everything else going on forward is essentially shot. So NDN configuration is fundamentally about names and security. And in fact, it's about those two things to such a degree that all configuration can be encapsulated in A, getting a name from a relevant application, and B, getting a certificate from the trust anchor that governs that particular namespace or administrates it. And from there, you can retrieve a trust schema, either from the trust anchor or from somewhere else. You can automatically discover namespaces. You can sort of autonomously do the play aspect, which we'll see later. And interestingly, this doesn't have to be a one-time thing, as it sort of mostly is in IP. You could quite easily imagine an already running application getting a new certificate to publish under a new namespace, or going through this process while it's already running, or in general, just doing it again. And I should also note, in terms of the application namespace, we generally are thinking of the DNS namespace. You could also think of users, as in the case of the example from the NP chat doc, having their own namespace. Great. And so let's, again, make this a little bit more concrete with something of a similar example. You have the network at your college or your work. You have some network at home. They're both running trust anchors to administrate them, and your machine is right here. So you have the name prefix /UCLA/NDN/B. You got it from an application. You have a certificate from one, since that's what runs it. The network as a whole has a bunch of individual nodes, each of which has their own trust schema. And they, as you can see, the trust schemas can be for trusting either anchor, for some given key name, so on, so forth. It's quite versatile. So in order to do configuration, let's say you're going through the same example, you're moving from one to the other due to some crazy unforeseen event. And because you're not actually fixed to some topology, you just move over to the new location, and that's it. That's all you have to do in terms of new configuration. If you wanted to, for instance, start signing under the namespace /home/C, for instance, you would first request, you'd get that name from some relevant application that wants to publish under that namespace, and then you'd get a certificate from the relevant trust anchor. This is the second trust anchor that runs /home. And that is NDN configuration sort of visualized and in a nutshell. And from there, we can think about how you play in NDN. So once an entity has the aforementioned essential components, you have your name, you have your certificate, you've got a trust schema in some ways. There are a lot of different ways to get connectivity. So you can do NDN broadcast self-learning, you could use NDND, you could use NDN auto-config, which I should note, because of the sort of somewhat confusing name, is not actually an auto-configuration system. It is a find closest hub system, so it sort of falls under this connectivity idea. You could be using NLSR. And you can actually be doing any of this over any sort of physical connectivity. NDN, excuse me, is somewhat agnostic as to whether you're using Bluetooth, you're using 4G, you're using Wi-Fi, you're using what have you. And you can even exploit the broadcast nature of wireless media, which IP in general cannot. And the above, or rather all of this, offers the opportunity to explore different options to get NDN connectivity and to discover available resources. Great. And so now we can somewhat more concretely talk about what we mean by the differences between these two when it comes to the configuration stage. In terms of their primary focus, NDN is largely focused on identity and security to the point that once you have your name and you have your certificate, that's all you need for configuration, or at least all you need for the manual part of the configuration, whereas IP is mono-focused on connectivity. In terms of the band that they operate in, NDN does have some out-of-band requirements for security and for configuration. This is the name, this is getting your certificate. IP is all in-band because once you've actually, to set up connectivity, once you're physically connected, you can just run DHCP. And there's a sort of minor, maybe out-of-band requirement in getting a MAC address, but that's not very interesting to us and not relevant to the edge user, so we'll elide that. In terms of the namespace they operate in, recall the sort of diagrams and illustrations from above. NDN works in the application level namespace, whereas IP, you're working in a topologically namespace and sort of plugging into addresses that are topologically arranged. And in terms of security, NDN has relatively high levels of security, given that you can ensure authenticity once you've actually done your configuration, and IP isn't really concerned with security. So the differences arise largely from the time in which they were developed. IP was designed 40 years ago for the sake of connectivity, and it works very, very well for that task, as it did then. But modern applications run in the DNS namespace, and they use TLS for security. NDN is younger. It was developed more recently. It saw those developments and had the opportunity to capture those new needs in the design itself. That said, it's worth noting that most applications do use IP and TLS sort of in conjunction. And there are a few reasons we're not going particularly far in talking about TLS. The first is that a sort of DDoS attack, source address spoofing that we already mentioned. Secondly is the fact that TLS is not necessarily the default that gets used. Just as an example, the majority of websites only started switching over to using TLS in 2018. And finally, the sort of most fundamental point is that TLS can't use the decentralized and localized trust model that we think is a good idea and that NDN sort of tends to employ, as we've seen in the NP chat model and in general in the other talks that the NDN community has given. The NDN trust model tends to be local and decentralized, which TLS in general cannot also do. So now we can talk about ways to actually implement plug and play. And to our view, the way to do this is to try and make the configuration stage of plug and play as easy as possible by automating steps. Notably, as we've mentioned, some of these security steps, getting your name, choosing your trust anchor, getting a certificate, can't necessarily be automated, but we want to try and pare away the bits that can. And to that end, we also want to make it easy, provide easy ways to safely input those trust anchors, certificates, name sets, and then automate connectivity beyond that. And so just to give an example of that, our contribution work is available on GitHub. I think everyone has the slides, so you should be able to follow that link. To explain it, it's relatively simple. It connects to other machines in one-hop Wi-Fi or Ethernet range. You have one machine that is designated as the anchor, which is the trust anchor. And other machines then request a certificate, and they receive one with the name specified by the server, or more specifically, by the server, and then the name is chosen by who ran the server. That's a setting that's configured. And you can imagine doing this multiple times while an application is running if you wanted to continue with the multiple configuration thing that we mentioned earlier. And so to go over how this works, this is sort of separated by time. You start off with having some trust anchor that's been configured. It has some security identity, let's say /NDN/config. You have two nodes that only have the default localhost/operator security identity. One of the nodes first sends an interest, a la /NDN/config/ some required info, nonce. It receives a relevant security and then certificate, and then installs a new security identity and actually also installs a trust schema from the anchor. And then the other node repeats the process. And so we can actually see a demo of that right here. So we have, in this case, one Mac that's running the server, 2 Raspberry Pis. So we start off by actually going ahead and starting up the Mac server. But first, we'll sort of go over the different options that are available. So we can see here that you first can note the prefix of the system that the people will be publishing under, and you can note the convention. This is what sort of name that the nodes will get when they sort of request something. And so here we have the first Raspberry Pi. As you can see, it only has the localhost /operator default security identity. Its configuration has not been done yet. It runs NFD. In this case, it's been configured to send that relevant interest and then to retrieve the new security identity. So we can see here that the security identity has actually been configured. Before the convention that was said was node, and here it's myndn/node and then some numbers that preserve uniqueness. And we can see it here that it's actually also had a trust schema installed. Yeah, as you can see here, it retrieved a trust schema from the trust anchor while it was also getting its security identity. This is one way to make configuration as easy as possible with relatively few commands. We could also demonstrate the second Raspberry Pi going through the same process, but I am of the opinion that it wouldn't be particularly enlightening for anyone. So we're actually just going to go ahead and continue forward. So a brief note on how we think this can enable applications. 2 applications that have recently been produced by the NDN community are NDN-SD and NP-Chat. And it's our hope that this sort of easy configuration can help enable those applications to actually sort of run and to achieve sort of wider use. So NDN-SD is a service discovery and publishing mechanism. It does this via synchronization over namespaces. If you wanted to discover a resource like printers, you run synchronization over the namespace /discovery/printers. And this application assumes that trust relations have already been configured. People have their certificates, they have their trust schemas, they know who to trust. And so instead of having to go through and manually configure your printer and every node that wants to use the printer, we hope that this sort of application that we've developed can help make that much easier than it currently is. NP-Chat is another wonderful application that's been developed by the community. It's a decentralized multimedia sharing app. It works off of an application level pub sub model. And though it does have the ability to trust someone by scanning a QR code if you're meeting them in person, if you wanted to also meet someone over some local network and talk to them and get introduced that way, you would sort of hopefully have existing secure certificates that you can use to trust them and establish that sort of thing. So great. Now we can move to future directions for this kind of work. We're hoping to further clarify the differences between IP and NDN configuration. We know that we were for sort of a long time exploring what exactly that looks like and trying to clarify what that looks like within our mental models. We hope to develop our tools so that they can support more complex use cases. Just to give a couple of examples, you can imagine pure NDN consumers, which may or may not actually need to go through this trust process because they aren't actually producing any data. So they may not need to get a certificate and actually interact with the trust anchor that way. You could certainly imagine developing some systems that don't require to be in 1 hop Wi-Fi range. You could imagine moving all this, and this is probably very much a good idea for future work, onto the NDN cert system, which wouldn't give you the trust schema, but is the good NDN way to do to get a certificate. And these are sort of all things we're hoping to do. We hope to further develop the automation tools for connectivity and to sort of make it very easy for that to happen. Since we've hopefully shown that you don't need to do something manually there. And we hope to integrate these 2 sets of tools into sort of some nice plug-and-play software that users and developers can use to easily, make and deploy applications that don't require a lot of manual configuration when you're setting up new nodes, since that can be somewhat painful if you're trying to set up a bunch of devices. So I think I actually went a little bit faster than I thought, so we'll have a good bit of time for questions. So in conclusion, as NDN developers, we should try and understand what the fundamental requirements for configuration are, which we hope to show that are your name, your certificate, and then pare away the extraneous pieces and make it easy for that to automatically happen. We want to make playing with NDN as easy as possible and as seamless an experience as possible. And actually, set up for a lot of this playing with NDN is actually in the next is the topic of the next talk, which I'm very excited for, and I hope everyone else is as well.